everybody at Lamar's for giving me this opportunity to present and to share with you some of the information and some of the people that you work with, the importance of what we consider one of the most important parts of power quality, which is surge protection. Now, I'm not here to sell, I'm not here to teach. I'm here today to share with you some of the things that we've seen that have helped not only our company, but our partners like you increase your business, increase your sales. But more importantly, the topic of surge protection is a topic that a lot of customers see as a value add. It's something that a lot of people don't talk to them about. And when you come with a solution to some of the problems that they've been seeing throughout the years, it makes us have a better relationship with our customers throughout the years. So what I'd like to do is I'm going to not just talk about products. I'd like to talk about the problems that surge creates, what causes it, and then we'll go into how to solve these problems. Then we'll get into some of the products that solve the problems. But I'd like to get everybody to kind of understand the whole process of how this works. So we talk a lot about the need for power quality. Power quality depends on several things, but the effects of it is downtime, loss of data, inadequate operation of critical equipment, costly repairs. All this relates to loss of money. And if the customer is not losing money, they're not going to listen to us. So a lot of what we do is we try to work with the customers to make sure that they are covering the areas that are costing them money. When we talk about power quality, we talk about 6 topics. Grounding, which is the most important. The next most important is voltage transients, electrical noise, harmonics, voltage fluctuation, and blackouts. And some of you that I've met in Chicago when I was there in February told me that you also sell other equipment. A lot of you sell UPSs. And some of the customers say, well, Miguel, the most important product that we need in power quality is a UPS. And I tell them that first we need to make sure that grounding is done right and then transients are covered. And why are transients higher in the totem pole than UPSs? They say, well, if power goes out 30 minutes, I lose 30 minutes of power in my production line. I lose $500,000 worth of production. And I say, yeah, but when the power comes back, you also need some startup time. So let's say you lose an hour worth of business by losing power 30 minutes. But what happens if a transient comes in or something generates a blockage in your equipment or damages a board? You might be down for days while you figure out where the problem is, where you figure out how to replace the board. And that's what we've seen in a lot of our customers, the manufacturing facilities, the data centers, that whenever they see a problem with transients, it's not just a 5-minute, 30-minute problem. It's a week-long problems and millions of dollars. So today we're going to concentrate on what's called as voltage transients. And I'm going to discuss a little bit of the misconceptions that we see in the market. A lot of people, when they see transients, you refer to it as lightning. And, you know, transients is lightning or something that comes from the outside. And as you can see, only 35% of the transient problems come from the utility side. Either lightning, yes, substations, transferring, other things that can come into your building and cause havoc. But as you can see, 65% of the problems with transients are not related to lightning. So some of the customers that I have in areas where there's not a lot of lightning, they tend to give me the excuse of, well, I don't need it. There is no lightning around here. But what they need to see is that 65% of the problems are actually generated by their own building. If it's a factory, they have equipment that starts and turns off all day long. So unless the factory is turned off, there are no transients. But we separate the utility side as something, the protection that comes from the outside is a preventative problem. But when you're talking about 65% of the problems that are inside the building, it's corrective. They have transients. They just don't know it. And transients could be large, that could damage equipment, or could be a smaller amplitude, which are continuously degrading their equipment. So we're going to separate both. We're going to talk about the transients that come from the outside, how to solve that, how to create a barrier from the outside problems. And then we'll talk about the problems that are generated inside the building and how to solve that, okay? So a very visual picture that we have here is just a map, and it gives you the areas in a particular day where lightning is generated. And people say, well, lightning, we only see it once a year. In California, I don't see a lot of lightning. When we have lightning over here, my kids are glued to the window. I mean, it just happens once in a while, and you got to enjoy it. But if you go down to Florida or other areas, I mean, it becomes a nuisance. There's a lot of problems with that. But in any given day, there's lightning everywhere. Okay. Now, let's talk about, again, we're still talking about the external problems. So lightning can come in a conductive manner, which means that everybody in the United States, any important, have a lightning rod. And these lightning rods are there designed to be able to attract lightning in order to protect the building. So a lot of the arguments, or some of the customers tell us, well, we don't need surge protection because we have a lightning rod. That's there for that purpose. But what that does is it attracts a high level of energy, high frequency, that's going to go into a rod down to ground. In that process, though, it gets induced into the electrical system. It's designed to protect the building, not the electrical system. On the contrary, if you have a lightning rod and it attracts a lightning, it's going to induce a lot of energy into your electrical system. And one of the examples that I love is Cristo Redentor down in Brazil, Rio de Janeiro, where you see lightning. I mean, not even Jesus gets saved by this. You get a high dose of lightning coming into one hand, and you can kind of see a little bit of current leaving on the other side on his other hand, right? So this is what you call conductive energy. But the most problems that we see with the utility are problems that are induced in the power lines. So when you induce power on the power lines, that means that energy comes in and it is being ionizing the air, and it creates a huge spike into the electrical system. That spike will continue, and go down into a form of, into any way that it can get to ground. And that way could be through a surge protection device that's designed to drain all that energy into ground, or it could go in your building and then go through other equipment that is grounded in your equipment. And that's where you see problems, okay? Now, the other form of problem is substations. It's ideal to have a substation close to your facility. That gives you stability in the power. That is good to have voltage stability. But utilities, or the substations, they are a great source to attract lightning as well, that can be then transmitted to anything that they're connected to. There's arc flashes, or there's just simple maintenance. When you have a substation that transfers from one substation to the other to do maintenance, or they have power factor correction capacitors, or anything that has a large amount of current being transferred from one end to the other in a quick manner, then it's going to generate the current going through the electrical utility lines into your facility. So these are the problems that are coming from the outside. And basically what we're seeing is a lot of energy that's riding on top of the sine wave. A lot of energy, high frequency, riding on top of low energy, 60 hertz. And that's going to try to find its way to go down to ground in any way that it can. So what we see is that anything from the outside coming in, large amount of energy, we're going to try to create some kind of drain at the input of the building to protect against the outside. Or else it'll go inside the building. Now, here's another thing that the customers have told us. Remember, I've been doing this 28 years, almost 30 years. So I've heard a lot of the reasons why not, okay? Until they have an issue, then we come in to solve a problem. And what we're trying to do here is trying to prevent the problem. A lot of the equipment, rectifiers, even Lamar's rectifiers or UPSs, any brand, they will all say that they have a surge protector inside, an MOV. And that's true. And even the servers, any kind of equipment will have its own level of protection against transients. But it's the last point of defense. What you don't want is to allow all that high frequency energy to enter the chassis where the equipment, the electronics are located. So what happens is that if you depend on just the last level of defense, the surge protector, the MOV that's inside the equipment, what happens is it might, if the amplitude is the right amplitude, it might attenuate that energy, send that energy to ground without burning the equipment, but it'll dissipate energy without the circuit, throughout the circuit, lock the circuit. That could, stop production line. It could also be degrading the components. So instead of having a 5-year life, it might just give you 1 year of just continuous, kind of like a drop on rock. It'll just continuously be receiving transients of low magnitude until it just dies. And there's no reason, you don't see any reason. There's no lightning outside, but the equipment died. Motors are being affected. Circuit boards are being affected. Even the MOVs that are inside the unit that are designed to be able to protect the circuit itself get burnt because they only have a very limited amplitude to be able to protect. A lot of times the equipment or the manufacturers will have the MOVs sized big enough or large enough to be able to comply with certain norms, but not necessarily to protect against external transients or transients that are higher than what's required. So the MOVs, like I said, like you see on this last picture here, the MOVs are designed to be able to attenuate as a last point of protection, assuming that you've taken the proper steps along the way to get to that point. So severe damage to problems caused by voltage transients or severe damage to circuit boards as we've seen. One of the big problems that we see now are ATSs, automatic transfer switches. 2 days ago, I was given a training to sell automatic transfer switches in North Carolina. And they see a lot of problems with the whole building is dependent on a generator, an emergency power system. And what happens is that the generator could be in great condition, but if there's something coming from the outside, some kind of transient comes into the building, the very first thing they see is an automatic transfer switch that has electronics. And that's there in case of an emergency to transfer the power to a generator. Well, under these emergency conditions is the time where you realize that that automatic transfer switch will either not transfer because it might see a certain level of transient, or if the transient is higher, it actually burns down. And they're trying to solve problems with their generator when it's in actuality, they need to put a surge protector to protect the ATS. This is similar to, in California, all of California was burning down recently, and every year it burns down. But we had one case where a fire department burnt down, and it's because it didn't protect. It didn't have all the protection around it. It didn't clear all the bushes around it. So you have a fire station that's there to protect you in case of an emergency, kind of like a generator, an emergency power equipment. But when it came down to the time where you really need it, the fire station burnt down. The generator won't start. So an ATS is, we're working together with some of the ATS distributors that need to protect their equipment. People who sell UPSs are also selling the UPS, but they include surge protection to protect not just the UPS, but also anything else that's connected to it. People who sell rectifiers, you guys that work with Lamarche, not only are you providing a solution for them in terms of conversion from AC to DC, but let's go a little bit beyond and provide protection for the rectifier itself and anything else that's connected to it. Again, we are becoming consultants. We're adding value to our customers, not just giving them a product that they may have requested, but you explain a little more of what the importance is of protecting against other auxiliary problems that could affect. In any of these cases, most manufacturers will not warrant will not give the warranty if the problem is not a manufacturer's defect. So, like I said, some of the UPS manufacturers that we're working with, they are actually either providing their distributors with a product like ours. Lamarche is doing the same, providing you guys with the opportunity to be able to have great access to these products that will not only protect their equipment, but also in addition to their customers. Some of the generator companies are including now our surge within their ATS equipment. There's a lot of need for this, and it's exponentially growing because of so much electronics. So again, the increase of electronics and communication in critical loads is exponentially growing. Servers, communication equipment, automatic assembly, medical diagnostic equipment, industrial machinery, generators, rectifiers, UPSs, you name it, everything has electronics. And electronics still have a very low tolerance to, on their dielectric to handle any kind of excessive voltage, especially now. And I'll explain that a little bit later. Are there any questions? I'm talking a little fast because I know that we started a little late, but Roberto, do you see any questions or anything that I should slow down
on? No, I think you're okay. I haven't seen anything pop up.
Okay, good. So causes of transients outside the building, just a quick summary. Lightning is the most visual, and those are the people, that's why Florida has the highest sale of surge protection, because they actually see lightning, okay? And North Carolina, South Carolina, all that area where you see a lot of lightning, Puerto Rico and other countries that I work with, anytime there's a tornado coming, man, the sales go through the roof because they know that visibly there's something going on. Substation switching, capacitor transfers, nearby buildings, if manufacturing facilities in an industrial park where you have another building that's creating some kind of transients, equipment turning off, equipment turning on, power factor correction capacitors, all that will generate transients that will then go back into the utility, into the substation, and then go back into their building. So those are cases where we see a lot of need, and a lot of people can visually see that. Where there's a lot of misconception is on the inside of the building. People don't realize that their own equipment is creating transients. So 65% of the problems are these. They're not dependent on atmospheric issues. They're dependent on your own facility. So like Lamarche has manufacturing equipment and everything, we've protected that against surge already. And other customers of ours that have important manufacturing equipment that need production to continue will go through this. We just protected Daimler out of their truck division. They lose $500,000 per minute if their production line goes down. Now, it's not just one equipment. What happens in a production line is that it's all tied together. So if one machine locks up because of a low magnitude transient, if it's a higher magnitude transient, it'll burn it. But if not, it could just lock up. And all that needs is for it to lock up for 1 second and the whole production line stops. So we've just gone through and looked at their one-line diagram, and we've already provided a solution for their facility to have continuous power. Motor starts, power factor correction capacitors, any kind of heavy machinery that turns on and off will generate a transient. Well, it's a big spike in current at that moment. Short circuit problems, maintenance errors will also create some kind of short and create a transient that will just generate throughout the electrical system. Again, I speak a little fast to be able to give ourselves some free time for questions if we need to. Okay, but again, anybody have a question, we can always address it. So here's a little drawing of a capacitor switching inside a building. So there's a lot of people that have power factor correction capacitors in the building, and anytime they have that capacitor switches from one capacitor to the other or corrects, it'll generate a transient. So equipment that's designed to solve one problem are creating other problems. A power outage. Sometimes a power outage is better just have the power stay off. The power will, you see the sine wave going, and then all of a sudden it stops. Well, at that point, it's not a problem. The units went down, the power went out. But when it returns with a vengeance. It returns with a spike, and that could burn down the equipment. So a lot of times people see that they have their equipment damaged when there are power outages. But it's not the outage that damages it, it's the return of power that will damage the equipment if it's not well protected. So like I said, a lot of the reason that we've seen an incremental growth of problems that are in facilities, when I started this, like I said, almost 30 years ago, we would go into a factory and we would see all the heavy machinery on one side, we would see the controls on the other, we would see the little data center on the mezzanine over here, 3 different areas completely isolated one from another. So it was easy to protect. We just create an electrical shield against one versus the other, protect itself adequately, and we're done. Now, everything is integrated. Not only are all the buildings integrated, but also all the equipment within a building is integrated. One equipment relies on the other. There's data, there's data center infrastructure management, there's IoT, IIoT, industrial Internet of Things. There's Industry 4.0. Everything has to communicate now. So the effects, one little effect on one little machine will affect the whole production. And that's what's causing millions of dollars in losses, not because one little transient will burn the whole building. It's one little transient will stop one equipment that affects the rest of the production and the communication. And what we're trying to do is help this guy. This guy is sometimes just trying to make some sense out of everything. One equipment goes down, you try to fix it, and while you're fixing that one, another one goes down. And that's the kind of customers that we tend to work with, or our distributors tend to work with, that we help them solve their problems. So it's just peace of mind. A lot of, I was talking to one guy the other day, and I was asking him, you know, do you get paid more because your system goes down at 3 in the morning and you get calls at that time? Or, you know, do you get paid the same if everything works properly? So what we're trying to do is make sure that, you know, one is he's going to keep his job because the system's going to continuously work. And two is that while he's working there, he's going to be able to at least avoid some of the problems that we can help him take care of. And that way he can concentrate on other issues that we don't have control over. So those are the problems. That's what causes it. Now let's talk about the solutions. And the solutions, I see that a lot of people do not have surge protection, which is a good thing. That means that there's a lot of potential out there for us to work with. But they don't have it, not because they don't want it or they can't afford it. It's because no one has explained it properly. The people that I talked to this week, like I said, that are the ASCO automatic transfer switches, some of their customers have not been introduced to this. How do you solve this problem? Do you just fix it, or can you prevent from it happening? So what we try to do is simplify the conversation that you're going to have with your customers so that it doesn't confuse them even more. And all we have to do is look at three simple steps to be able to figure out how to solve this problem. And I'm going to refer back to IEEE C62.41. They give us 3 categories. Category C, which is a surge protector that's designed to be installed at the input of a building. Category B is a surge protector that's designed to be working within the building. And category A is a surge protector that's designed to be connected directly to the equipment you want to protect. Obviously, it makes sense that category C is going to be a larger unit because it's there protecting from anything coming from the outside, anything coming from a substation, a lightning, everything we just discussed. Category B will be a surge protector that's designed to work to protect against elevators, against air conditioners or other equipment within motors or anything that can start and stop inside a building. It's still a good size transient that could be generated, but not as big as the one coming from the outside. And category A is really designed there to protect, assuming that you've done a good job with C and B, because it's a lesser level of protection. And then you also have additional protection inside the rectifiers, inside the UPSs, but you want to keep the transient outside of that chassis so that the electronics of the expensive equipment does not get affected. Surge protectors are considered like the pawns in a chess game. The pawn, not the king, not the queen. The king is going to be your equipment that you're trying to protect. Your queen is going to be your rectifiers, your UPSs, and the pawns are things that we're going to put everywhere to try to eliminate the problem before it gets too close to our king and queen, right? So category C, B, and A. Now, the second point is KA, kiloamps. There's a rule of thumb that says that category C, surge protection, should be around at least 150 KA of protection. Most manufacturers will manufacture from 150 KA to 500 KA of protection, okay? So anything higher than 150 KA, you can put at the input of the build, at the entrance of the building. Category B, and I'm gonna give you guys a couple of real life examples with some one-line diagrams, so it'll make it more visual, okay? Category B, we're looking at about 100 KA, so somewhere between 100 and 150 KA. And then category A is going to be around 50 KA. So 50 is your minimum, 50 to 100 is category A, 100 to 150 category B, and 150 and above is category C. The last thing you need to know is the voltage. is this panel, electrical panel that we're protecting at the entrance of the building, category C, at least 150 kA, and it's 482.27. That's all I need to specify my surge protection for that site, that location. Category B, 100 kA, 208/120. That's all I need to be able to recommend the right surge protector for that location, okay? I'm gonna simplify it a little bit more as we go along, but those are rules of thumb. Entrance, a distribution panel, and at the point of protection. Any questions on that? Now, this is what IEEE and UL recommend. So the category A, let's talk about category A. And you can't see my cursor, can you? Can you see it, Freddie? Okay. Well, I don't know why you can't see my cursor, but I'm pointing at category A. Let's look for at the where it says point of use. Okay, point of use is around 50 kA of protection, and anything and that's considered type 3. So some of your customers may recognize category C, B, or A, or the terminology could be type 1, type 2, type 3. So don't get confused on that. It's the same thing. Type 3 is category A. That means it's designed close to the load, around 50 kA. Category B, or type 2, is around 50 to 100, 100 to 150 kA of protection. Any panel, distribution panel, go around that range and you should be good. And category C, or type 1, could be at the entrance of the building. Now, if you see type 1, it goes the long range. You can put a surge protector that's 150 kA all the way and connect it right to where the load is. It'll work perfectly. There's no reason why not. The problem is that if a category C may cost you $2,000 and a category A would cost you $300, you might not need to put a $2,000 piece of protection where you can use a category A and be able to reduce the price. Also, the size of the unit will be a lot smaller if you go closer to the size. So will category C and type 1 work throughout? Yes, but it's more practical to try to stick with the rules of thumbs that I'm giving you because it'll fit more the panel that you're protecting. I hope that makes sense, okay? Now, I wanted to explain this first. Are there any questions on this before we go into more visual? We're gonna make it simpler and simpler as we go along. Okay, so let's just understand this way now. If we have the utility at the entrance of the building, and we have a larger surge protection device, type 1 or category C, then in here we have the next two panels are distribution or branch. That's inside the building. Not every building just has one panel and then directly to the load. A lot of buildings have different distribution panels, and then it goes to sub panels or branch panels before it gets to the load, okay? So if we look at the input of the building, we have a surge protector there that's category C, about 150 kA, okay? And it's 482.77. Boom, done. Category C. Now we're isolating all these problems from the outside are now protected. Now let's just worry about 65% of the problems that are generated inside. Any one of these panels that are inside the building are category Bs that are going to be between 100 and 150 K. Those are there to protect as a secondary measure from anything that came from the outside. You can see that the outside will attenuate a certain amount, but there's still some residual going in, and the second part of protection will continue attenuating all the way down. Every step attenuates even more. But there are some people will say, well, if I have a category C, that's all I need. Remember, I'm going to give you some of the reasons or excuses that people tell me. I just need an input surge protection. Okay, that will protect from anything coming in from the outside. But again, if you have a generator inside the building, if you have an air conditioner, if you have motors, if you have anything that is operating throughout the day, that will be generated in the inside of the building. That transient will not go all the way to the input of the building to go to ground. You need another surge protector within the building to be able to attenuate and be able to deviate that energy to ground closer to where the problem is being generated, okay? And then you have your category A, which is closer to the load. Think of this as a drain, like water. A lot of people can understand this even easier when you're talking to your customers. Explain it like water. Electricity, current, water, it's all about the same if you explain it in those terms. So if there's a large rush of water coming into the building, you're going to have a big drain on the street, right? You're going to depend on that drain to keep that water away from your building. But sometimes you also need a secondary, you also have some kind of drain within your building or at the entrance of your building. So in case there is a surplus of water and that drain doesn't necessarily go down, doesn't deviate all that water out, that remainder will then have a secondary point of attenuation to be able to drain that water out before it gets to your critical equipment, before it gets to your house. Then you have your category A, which is really like a drain inside your house, like a bathroom or something. If something bursts inside the bathroom, you want it to go out that drain. But that drain or that water that's going inside your bathroom is not going to go all the way down to the street to drain itself. You have to have something closer to the source where the problem could be to be able to deviate that problem, okay? Obviously, anything inside the bathroom is not going to be the same as if there's a storm or some kind of flood coming in from the outside to your building. So each one of these drains has to be sized properly to be able to resolve your problem. Going to the other issue is saying, is the surge suppressor too big? No, you can have a drain the size of the one that you have on the street in your bathroom and it'll still solve the problem. It's just an overkill, okay? But will it solve it? Yes, it'll still drain. Here is the input of the building. So now let me give you some practical experience. This is a recommendation from, actually ASCO sent me this. And it says SPD should be installed on the load side of the service entrance generator and transfer switch where it's shown in position SPD1 and SPD2 and SPD3 and SPD4. They recommend surge protection everywhere. I would say that at least you need, if this is your automatic transfer switch, and there's electronics in here, and this is your service entrance. Oh, I'm using my cursor, sorry. So from the utility side, if the energy is, there's a transient coming in from the utility side, you want to have SPD1 or a surge protector at the entrance of the building, on the panel of the building, okay? That will protect the electronics on the surge, on the ATS equipment, the electronics. Now, you also want to have an SPD3, the one that's on the bottom that goes on the panel. That's your category B. What happens is that when the generator kicks in, it'll generate a transient as well, and that will go down, and you want to protect it before it goes to the rest of the equipment that's connected to the next panel, okay? So you have your category C at the input of the ATS, and you have your category B at the output of your ATS. And that's how they recommend it. If you go over here, it says SPD2 protects the generator, SPD3 protects downstream loads, and it's arguably the most important SPD in the context. So yes, the SPD3 in their example is your category B. That's there to protect from any transient that the generator creates, but it's not protecting the generator or the operation of the ATS itself. That's where you need your category C. Let me give you an example. I wish I could show you with my cursor, but let's go to the top. Okay. Laser pointer? Can you see? Aha, okay.
Perfect.
We got a laser pointer. Thanks, Freddie. So we have the input of, now this is an actual customer of mine that we are designing their data center. They have a data center that has redundancy. So this is the input of the building. Here's a generator 1 or generator A and generator B. As you can see, there is this mirrors input A is copied in input B. So you have redundancy. In case one of the side goes down, you have the other. So this is a very critical load. So you have the input of the building. And here, this little box here, you don't have to see too much, but there's a little box here. And that little box is my surge suppressor category C. In this case, we have a very big customer. A lot of losses could be done. So they decided to go with the highest KA rating, which is 500 KA, okay? They figured that as long as they protect against any kind of lightning, we're good. So the difference between a 300 KA, 400 KA, 500 KA is a couple $100. They said, put in the biggest thing you got, okay? So we're gonna go with 500 KA here. What is this protecting? Let's just go down input A. This is protecting the automatic transfer switch that's going to decide if the generator kicks in or not in case of an emergency. So this surge protector is here to protect the automatic transfer switch. Now, let's assume the generator kicks in. That will generate a transient, a spike in the energy that will go into this electrical panel. Here we have a surge protector category B, okay? Now they oversized a little bit. So their category B was gonna be between 100 and 150. They said, let's just go 200. So they went with 200 in this case, but it could have been 150, could have been 100. But oversizing a little bit more, like we talked about the drain, is not an issue. So this kind of customer merits that kind of. Then from there, we go to another panel. Now this looks very close, but there's distances between these panels, obviously. So this panel here is going to feed two large UPSs. Now each UPS is about $30,000, $40,000, $50,000. Some of these UPSs are over $100,000. So they want to protect the input of the UPS with a 200 KA surge protector, right? Now remember, we've got category C, and we have category B and a branch panel category B. So we have different cascading levels of protection. It's not so much the cost of the UPS, which is, the category B surge protector will cost you, under $1,000, but it's protecting, let's just put a number on it, $200,000 worth of UPSs. But what they're really protecting is the continuity of operation of the rest of their system. They make money on the operations of the system. So they will lose millions here when they could lose just hundreds of thousands in the equipment by providing a $1,000 piece of surge protector, okay? So depending on the sizes, the cost of what we are trying to offer is insignificant to what we are protecting, okay? So I think, see if I can stay with my, oh, it worked, okay. So here's another drawing. Now this one is an insurance company. We have, we're working right now, as a matter of fact, we just got the job yesterday. We got the letter of intent yesterday for 25 buildings for an insurance company. This is an insurance company that's going to have, every building was different. And one of the things that I like to offer LaMarche and all of you that are present is that we want to work with you. You're not alone on this. You send us a one-line diagram, we'll work with you, and we'll tell you exactly what size surge protector, what voltage. We want to make it easy for you. But I guarantee that once we help you with one, you're going to be on your own. It's not too complicated. So let's look at this one-line diagram and see if we all understand this. We have the input of the building going into the input surge, the input panel. This input panel would be category C, good. Even though everyone's on mute, I heard that. Category C, perfect. So we got category C at the input, and what we did is we recommended about a 250 to 300 KA surge protector at the input of this building because it had a lot of branches. They also had smaller buildings where we just recommended 150 KA. This one was a little bit larger, so 300 KA at the input. Then from there it goes to two distribution panels, 1 and 2. This one has a very local presence. It's just protecting equipment right here. So we went with about 100 and 150 KA surge protector here. And then we have another distribution panel where we recommended around 200 KA. Remember, the category B could be 100 to 150, but if you have a lot of equipment connected to it, you might want to just go a little bit higher if the cost permits. It's only, $100, $200, $300 more. So they decided to go with 300, 200, 150 right here, okay? Then from there, they go and protect. This panel right here is going to feed into several other panels, including protection of UPSs, There's a UPS here, there's a UPS at the bottom. And each one of these panels, they just decided to put a 100 kA surge protection device here. On the load side, some, not all, of their equipment, if they felt that it was critical, they had added another 50 kA protection. So there's rules of thumbs, but depending on the installation, you can be creative. So at the input, we had category C, we had 2 category Bs, and then we had sub-panels with lower KA ratings for them, as well as a couple of protected equipment here. We had some pumps, we had some controls that they decided to sprinkle in a couple of 50 KA surge protectors in these. So this is a sample of 25 of their buildings that we just received the letter of intent yesterday. Any questions on this? Nope. We're trying to make this so that it's visual. I want you to understand that if you have a situation or a one-line diagram, anything you can feed or that you can email us or go through the right channel, we'll be able to help you out with the proper solution. Okay. So let me show you some pictures now. Now this is a category C, but this one is actually kind of special. Most installations that you're going to see the input of the building being at 480, 277, or anywhere under 600 volts, right? 480, and then you got your 208, 120s, and that's 95% of our business. Some of you may have some industrial type customers, like Daimler in this case, okay? They have a transformer on the outside that's working at 4,160 volts. We do have surge protection that goes up to 5,000 volts. Now, I don't see a lot of people in the market that are offering this. This is a great opportunity. We have one of our distributors sells to the petroleum industry. They sell these type of surge protectors to be able to protect the submersible pumps. Submersible pumps have variable frequency drives at 4,160 volts. Not a lot of people have this. Because of that, it's a great opportunity for us. It's a great opportunity for you. This product will have a cost of about $15,000. This is our big unit, $15,000. But they sell it for over $20,000, $25,000. I'm just giving you ballparks, okay? Because again, a $25,000 piece of equipment to protect millions and millions and millions of dollars worth of operation is insignificant. And I'm giving you ballpark prices just to give you an idea, but each one of these has different characteristics, so you're going to have to be more specific on it. Now, this is a bank branch. We did all of their branches. We've done over 300 branches for this particular bank. And they decided to go with a category C and a category B. What they do is at the input, they put a 200 kA surge protector. How does this work? The transient will come in, high energy transient, instantaneous energy coming into the panel. First question that people will ask is, how come the breaker doesn't protect me? Well, remember, these transients are 1.2 milliseconds. They're in nanoseconds. These transients are very, very quick. High energy, high frequency, very quick. Breakers require especially thermal breakers require heat. They require current to be passing through there a certain amount of time before it can even notice it. So transients will go right through breakers without the breakers even noticing anything. Now, why do we put the surge protector right here, close to the ground? This transient will go into the panel, and it'll see that there's resistance, 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 resistance. Everywhere there's load, there's resistance, except it gets to a point where there's a short circuit, a temporary short circuit to ground. So a big surge of energy will come into the panel, go through the panel, and find its quickest way to ground, which the MOVs create a temporary short circuit drain to ground. So that's where the energy will go through, okay? None of the equipment connected to the panels will ever see any of the transient if the surge protector is connected properly. Here is a category, so that was category C. Here's the same building, category B. They have a smaller panel that's distributing power to a little data center, a little computer room. And this, again, power will go in through here, and we have a short circuit to ground. Anytime there's a transient, it will create an instantaneous short circuit that will provide a path to ground with least resistance. Category C, category B. We have a lot of our industrial customers that liked our category A. In that same bank, I didn't get a picture of it, but they put their category A surge protection next to their security equipment and next to their ATMs. That's where they, on a bank situation, I'll show you right now one of their drawings to see where they installed it. In an industrial facility, what they like to do is they like to, here they have 3 single phase. So they put our 50 KA surge protector, which is called the Speedy, and this will protect the controls and everything for their facility. Here is one of these connectors for a 3-phase protection here, where they have variable frequency drives and other controls. So to kind of give you a visual of how we install them. Now, that's your category A, B, and C that we just talked about. But I'm going to share with you, and some of you can see me. So your category B is like this size, just so you can kind of get a reference, okay? But now what I'd like to show you is, for those of you that work with industrial facilities, this here is a job we just finished for Heineken beer. They didn't have any funding, so they're going to have to pay us with liquid money. We've got a year's supply of beer. No, but what we did is they were having problems with their controls. So a lot of times at the very end of your electrical system, your equipment that's very sensitive, not just to transients, but also to electrical noise. And electrical noise is the same issue as transients, only it's smaller amplitude, but it still causes havoc in terms of the controls. So what we did is, every one of their power supplies that they had there, their Allen Bradley power supplies, they wanted to protect not only against transients, but also against electrical noise. And what this here is a surge protector that has a very strong noise filter. And you want to attenuate not just the transient, but once the transient is attenuated, you want to eliminate the noise. And let me show you how this worked. We actually have some readings for this. So if you see these yellow cables up on top, those yellow cables were connected previously to the input of this power supply, okay? So without the surge protector, we had just current coming in from here directly into the power supply. What we've done is we've just disconnected it from here, put our surge protection. This one's called a DSF. It's a DIN surge filter. It's a DIN rail type surge filter, so it has 2 functions. The input of the power supply comes in, the output, the filter, goes through here, and you can see the cables connecting directly to the input of the power supply. Very simple installation, very low cost. They put these everywhere because they were having problems, glitches here, glitches there, and we've been able to help them solve those issues. Now, let me show you what some of these measurements show us. If you have 122 volts RMS, which is equivalent to about 168 volts peak, okay? This is what the power supply is supposed to receive, 128 volts peak, okay, 122 volts RMS, perfect sine wave. All of a sudden, you introduce a transient of 421 volts. Here you see the transient. Without this protector, those yellow cables were going to inject 421 volts directly into the power supply. But no, what we've done is the transient side of this equipment will attenuate, will reduce the voltage from 421 to 266. That way, it's reduced from a transient to a noise level. 266 is now considered a noise level. It won't burn the equipment. 421 may have burnt the equipment. 266 will just block the equipment. It'll create noise to the system. But since it has a noise filter as well, we've been able to attenuate the 266 to 169. So in essence, the normal voltage is 168, but because we have transient and we have filter, the equipment will only see an increase of 1 volt at the input of the power supply. So continues working even under transient conditions and electrical noise conditions. If there are just electrical noise conditions throughout the day, it'll attenuate it to 169. So you're able to see that you start off with a sine wave, you go through our filter surge protector, and you continue with a sine wave, that this is what the equipment is going to see. Any questions? Okay. Now, again, we've already done category C, B, and A. We've taken care of that, but we're showing you some equipment that I think are very useful and that not a lot of people have in the market. Right now, this is another piece of equipment that we just came out with this year. And this is what's called a PQM, Power Quality Monitor. Why did we come up with this? This is because not only are all these panels that need protection, but everybody wants to have a visual on what's going on in their building, okay? So we're using this strategically, and I'm gonna share this with you because this is how some of our customers are really doing well with this product. Not only are these customers experiencing transients, but a lot of time they can't see it. They don't visualize it. You might install a surge protector like this, or like this, and you'll install it there, and it's just continuously protecting them, but they don't know that. They don't know how well or how many times you protected them that day. So what this does is this takes measurements not only of how many transients, the duration, the amplitude, so it gives you credibility. You install this in a panel and you go back and you say, look, how many times this has really protected you throughout this time. Also, it is a power quality monitor, so it also monitors against voltage variations. It can give you up to 2,000 readings of how many times the voltage has gone up, has gone down, voltage THD, so total harmonic distortion on the voltage side. It gives you how many times there's been power outages. And all this you can have, you see the Ethernet connection there. You can plug it in and you can download it to your laptop, or you can have it in your internet system so that you can remotely be accessing the information on your iPad, on your phone, on your computer. You can store this. Now, some of our customers are saying, well, this is pretty cool, but most of our guys don't understand power quality. So what do we do with this? What do we do with all this information? So a couple of our distributors, they've offered that if the customer provides or installs this in their facility, if they buy this product, they will go for the I was muted there?
Yes. Okay, now I can hear you.
How many hours was I muted?
No, it was very briefly.
Okay. All right. Well, we'll continue then. Everything back on track? Okay, good. So what some of our distributors that understand a little bit of power quality, they say, you know what, we're going to offer you not only if you install this in your panel, and we've done this, we've installed these in category C at the entrance of the building, or we've installed it into some areas that they feel are critical to their operation. And they want to have a visual of what's going on, but they figured, well, we're going to have 2,000 readings here, and my guys are not going to know what to do with it. So what our distributors are doing is they say, you know what, for the first 2 years, every 6 months, I'm gonna download all that information. I'm gonna write a little report for you based using that information. Strategically, customers love this, but our distributors love it even more because you don't walk into a customer and ask them, hey, any problems? You already know what problems they have. They have either voltage surges, voltage sags, they have power outages, they have different things, and you're privy to all that information firsthand, while at the same time you're providing the customer some value add to what you're providing. So this is called a PQM, Power Quality Monitor, and like I said, it's got those added benefits of not only protecting against surge, but also at the same time measuring the problems that you're having with voltage throughout a long period of time. Now, again, what are some of the things that I've seen our customers tell us is they say, well, you know what, we have a surge protector already there. No problem. If you already have your panel protected, that's okay. You just don't have visibility of what else is going on. The other the other issue that I've seen is some people have a power quality monitor installed in their facility. What we've seen with power quality monitors are, one is that they're not cheap. They're pretty costly if you want to have a good one. But the other thing is that now you need a surge protector to protect the power quality monitor, because that power quality monitor is pure electronics and is connected right at the input of the building. So unless you have that power quality monitor protected with a surge protector, whenever there are large problems, it might not give you the readings because that little monitor will burn down. And we've seen a lot of equipment that is designed to measure these power quality problems get damaged. So whenever there is a problem, you go and see it and the actual meter is damaged. So the fact to have a surge protector within the meter not only protects our surge protector, our power quality meter, but it also protects everything else that is connected to that panel. So we are providing 1, 2, or 3 levels of service that other people cannot provide. Okay? So this is called a PQM. Now, any questions up to now? I know we have just a couple of minutes, right? So let me go a little faster here. We got a couple more minutes. How to select the right surge protector, just a little summary. You identify the protection location, whether it's at the input of the building, distribution panel, or a critical load. Main panel would be category C, distribution panel category C, and next to the load would be category A, or type 1, type 2, type 3, depending on the lingo that you want to use, right? Or that your customer wants to use. The next thing you need to identify is what the KA rating is required. So at the main input panel would be 150 KA or above, distribution panel 100 to 150, and next to the load 50 to about 100, okay? Those are just rules of thumbs, but like we saw in the drawings, we can be flexible and we can be creative. And then we select the nominal voltage, whether it's 480 or whether it's 208, 120, and there you have your product. Now I'm going to bring you to our website right here, and I'm going to show you that if you want to take a look at our website at pqglobal.com, you can see some really interesting things. Like if you're going to talk to somebody that has a data center, you go into this. Oh, shoot. How do I do this? Can you help me? This one? Okay. Can you see the 3D drawing now?
Yes.
Okay. So this is also in the La Marche website, right, Roberto?
Correct. Yes, it is. Mm-hmm.
Okay. So maybe I should have opened up the La Marche website, but the drawing is here, right? So you have category C, and you have the input of the building. You have a surge protector here that is protecting the automatic transfer switch. Oh, now you can see my cursor. Yeah. Boy, this is crazy. Okay. So we have category C surge protector right at the input. Let me make it a little bigger if I can. No, I can't. You protecting the automatic transfer switch. Now the generator is protected. Okay, there's power problems. The generator is protected. Okay, we have hope. Then we have category B, which is our secondary point of protection. And this is protecting the panel that's going to a large UPS that's then feeding the rest of the data center. And from here, we go to PDMs, or power distribution modules, which is basically a transformer with electronic distribution. And there we put our category B surge protector. This is this is similar to our AT&T customers. This is what they do. They put category C, category B, and category A, they put inside the what do you call it? The racks. If you go to an industrial facility, Some of you may be working with industrial facilities. And again, this is on the Lamar's website. So you can these are PDFs that you can download, and it tells you in their language. So if I'm talking to a data center guy, I'm not talking to him about, on this piece of literature, about robots and ATM machines and all that. This piece of literature is going to be very helpful because it talks about the things that they understand. So this is a design that we did based on a project that we did for Chrysler. And they were concerned about downtime. They were concerned about variable frequency drives, CNC, PLCs, robotics. So if you look at it, you have your category C, that is a surge protector at the input. Then you have a conveyor belt and a robotic line, both protected with category Bs. And then the variable frequency drives in here, very similar to the Heineken protection that we did with the DIN surge filter, we have category A. This facility also had a little mezzanine with a little computer room that had an air conditioner and a UPS that also was protected with a category B protector, okay? So this, again, if you look at the Lamar's website, you'll see these tools that are there under surge protection. And we partnered with Lamar's to be able to provide a value add to our customers. Most of our distributors that distribute Lamar's also distribute PQ Global products together with the Lamar's offering so that it provides a better solution to our customers and a protected solution. So let me see, I know that I have to do something crazy here to be able to get back to my tray. And I think here on my last slide, I'm just getting the hang of it. You can see it? Okay, good, because I couldn't. Okay. So that's where I'd like to end here, exactly at an hour's time of presentation.